Hello everyone, welcome back to MGF1106. In the first video, I already introduced what the set is. We talk about the definition of the set. We know the notation of the set and how we create a set. Now, if I go ahead and just grab some element of a certain set, okay, and I want to create a collection of those elements, the element I just grabbed it, then whether or not, the question is whether or not the element, the collection I just created, whether or not it's also the set. So in this section 2.2, in this video, I want to talk about the subset and the proper subset, and how we'll create the subset and the proper subset from the original set. Okay, so let's get started. Section 2.2. So I'm going to put over here. 2.2 subset. Okay. So what is subset? I just say that, right? I just said already. We just grab some element and we create a collection. So that is actually the subset. So on the first part over here, okay, the first part over here, I would like to talk about subset. Let's talk about subset first. Okay. Subset. What is subset? Given a set. So let's set A. This is a definition of the subset. Set A a subset of set B. Okay, even the set A over here, this is some collection that contains some item belong to the set B. Then I can write this is a subset of the set B. Then I can write A. Okay, with this symbol right over here. This is a subset. This is kind of this is like letter U, or, horizontal letter U, and this is a bar right here. Okay, so A is a subset of set B, notated as A letter U B, not the regular U, right? But it's just like a horizontal letter U. If every element in set A, if every element in set A, okay, is also an element. Is also element in set B. Whatever you have, whatever you see in set A, the element in set A, you also see that element in set A. That's what I mean. Because at the beginning I said we just grab some element from set B and create another set, right? Another collection, and that collection, yes, is also the set. For example, I have something like this. What if I have set A over here? Okay, and set A over here. Let me use the builder notation we learned in the previous video to create a set. What if I have a set A? Okay, and set A here. This is includes some X over here represents some planet of the solar system, of our solar system. So X is planet. Okay, X is planet in our solar system. Okay. Okay. And how many planets in our solar system? You already know that. Okay, and I'm gonna go ahead and create this set B, and set B over here. I use the regular notation we already learned in the previous video also, and over here I just put Earth. Okay, and let's say Mars, right? Okay. Okay, so you know that our solar system it has more planets than just Earth and Mars, right? There's a bunch of planets. We have Neptune, we have Mercury, and so on and so on. So you see that in set B over here has two elements, Earth and Mars, and these two elements here is also a part of our solar system, right? It's just a planet of our solar system. So I can say over here, set A is a subset of set B. It's a subset of set B. Okay. All right. It's a subset of set B. Okay. Some in later on we're gonna talk about a proper subset, and we can write a proper subset in the same way as we write the subset. However, we don't have a bar down here. Then maybe by that time I'm going to explain to you the difference between those two. But at this moment, I can write A is a subset of set B. I can write something like this. Okay, or I can give you another example. For example number 2 over here. How about if I have something like this? I have, let's see. Let's create another set. Okay, let's create a set. Set A over here is some. Let's see. Let's create a set over here. Let's say we have a set of some furniture. What do we have? We have bed. We have table. Okay, we have a desk. Okay, we have chair. Okay, we have what else? What else we have? We have different chair. We have how about we have this regular chair over here, and we have chair. Okay, something like that. Okay, so the cardinality for this set will be 1, 2, 3, 4, 5, right? So over here n of A equals 5, so we already know that. Then I can create a set B over here. Okay, so the set B over here is what if set B over here? I just have a table and chair and desk. Okay, so I can say over here set B. Okay, oh, I'm sorry. Set B is a subset of set A. Oh, I mean over here set B subset of set A. Okay, I'm sorry. Let me erase this really quick over here. There's some error right here. Okay. Oh, I cannot use pen for this. I don't know why it's not working. Okay. Let me rewrite it. I put in the other way around. So B is a subset of A. Okay. So from here I can also say that B is a subset of A because all the element in B is also the element in A. Then when is the case when it's not a subset? Okay, what if I create another set? Okay, how about example number 3 over here? Let me use different letters. So let's call it set C over here, and set C over here. Let me see. I can use. About like this. What if I have over here? I have Jack. Okay, King, Queen. Okay. How about I have diamonds. Okay. I have club. Okay. I have heart, and I have spade. Right. There you go. I have a set on this. So this has 7 elements over here, and in set D, I have Jack, heart. Okay. Then I have I have something else. What if I have what if I have something? What if I have so what else? What else I have in the card? I barely play cards, so I don't know. Jack, King, Queen. What if I have number 10? Oh, let's use a different one. There's nothing to do with card. Let's say what if I have I have a square over here. Here you go. I have a square. Now let's analyze it. So you see the set D over here. They have Jack and diamond. So look like this the element over here is also the element of set C. But however, in set D we have a square. So if we have a square over here, so square does not belong to set C. So sin, okay, the square, okay, element square, it does not belong to, we already learned this symbol last time, belong to set C. So I can say that the set D over here is not a subset. Okay, let me use this. This is it as a subset symbol. Then they have a bar, like this, dash bar, slash bar like this. It's not a subset of set C. Okay, because according to the definition of subset of set, if every element in set A is also element in set B, but over here, this is in set D, have it, but I mean it's in set C, but I mean the square is not in set C, so I cannot say that D is a subset of C. Okay. All right. Now there's another case we can conclude out this example is this. We also can conclude that we can conclude that C is not a subset of D, right? C is not a subset of D because you see over here they have element element in C. Over here is some element in C is an element of D, but as you see the element of D over here, element heart over here and sweat over here, it does not belong to D, so they contradict to the definition of subset. So C is not a subset of D. We can conclude that way. Okay. All right. So that is the definition of subset. Now, what if I have two equal set? Then what happened? Well, I think I'm gonna before I get reach to that part, I think I'm gonna give you another example when we have a very special case right over here. Let me give you another example. I'm just afraid I'm forgetting, so I'm gonna give you that special case right over here. Now, what if I have another set right here? Okay, let's say that I have a set E. Okay, and the set E over here has some element. Let's see. Let's see what if I have. Let me. I just want to create another fancy set over here. Some fancy element over here. Let me think a little bit over here. So how should I create it? What if a set E over here has some car brand? Okay, so as an element, what if I have Honda? Okay, I have Honda. I have Ford. I have BMW. Okay, BMW. Okay, BMW. Oops. BMW. What if I have Mercedes? Okay, and I have Cadillac. Oh, I love Cadillac. That is one of my dream cars. I don't like Mercedes, but Cadillac is like, I don't know, it's looking more intellectual to me. So I really love Cadillac. Then over here I have a Toyota. Okay, Toyota. So I have the set like this. They have six elements. So the cardinality for this set is 6. Now, interesting is this. It say that I can create another set, and this set over here okay, this set over here has all the elements of set E. Now, what if I create a set F? Okay, and the set F had the same number of elements and the same element. So let's see, the set F is Honda, the set is also Ford, let's say BMW, we have a Mercedes, and we have Cadillac, and finally we have Toyota. Okay, we already know in the previous video, we know the setup over here, they're equal to each other, right? They're equal to each other. Now we can, based on the definition, okay, we can also conclude that a set E is a subset of set F. So look like that they are the same, they're equal to each other. So I can conclude that a set E is actually a subset of itself. And set F is also a subset of itself. Oh, interesting thing, right? So based on this example, what we can conclude? We can conclude that every set, okay, every set is a subset of itself. Oh, that's interesting thing, right? That's very interesting thing. Another case is very special case. Okay, another special case in this example here. Last time we also talked about empty set. We already talked about empty set. You remember? So empty set. Let's say I create an empty set of CC. This empty set G over here. Okay, we can write like this. Don't put a zero, okay? Because if you put a zero, it means not empty set anymore. You don't put anything, okay? Or you can write this, or you can write, or G is just something like that. So G is the empty set. A good thing about empty set is this: every empty set, okay, is a subset of all the set. So given a set A, so I can conclude that set G empty set is a subset of set A. Okay, so every empty set is a subset of a given set, any set. So from here, I can write you a first remark. Okay, it's very important remark, so it's just for you to remember. Let me use the different color over here. Okay, the first remark I want to mention is that the first one is that every set, okay, is a subset of itself. My baby is waking up, so I let my mom go to the room and take care of the baby. Then let me finish the video, then I go take care of the baby. Then the second thing I want you to remember is empty set is a subset. Okay, empty set is subset of every set. Okay, every set is a subset of every set. Okay. Okay. So now, so we already know that if set A is a subset of set B, then every element of A is also the element of B. That's what the definition of the subset. Now, if we go ahead and exclude the part that set A and set B equal to each other, because we know in the remark right here I say that every set is a subset of itself. It means what? It means that set A can be the subset of set A. Okay, because all element of A is also the element of set A. Now, if we exclude that part, then we will have another type of set we call the proper subset. So on the second part of our video here, okay, I will discuss I'm going to discuss. So let me remove all of this up here. Okay, I will discuss proper subset. Okay, proper subset. So this is a definition of a proper subset. If set A is proper subset, okay, of set B, okay, and we can write as follow. So we're going to use the same type of symbol, but instead of put equal, we just put the sideways letter U over here. So this is A. Set A is a proper subset of set B. If set A is subset of set B and set A is not equal to B. It's not equal to B. Okay. So if we go ahead exclude this part right over here, we exclude the part right over here, then we have a proper subset. Okay, not just a subset. Okay, not just a subset. We have proper subset. For example, okay, let me jump to the example right away. It's easier for you to understand. What if I have this? We have set A is 2468. Okay, 4 element, and over here I have set B. Okay, set B is 24610. 246A10. Okay, so over here we can write that set A is a proper subset of set B, or we can also write that set A is a subset of set B. Okay, so there's two different ways to express this situation. Okay, so all element of A is a part of element of B. That's why we can write that A is a subset of B. But we can also write that A is a proper subset of B, because A and B is not equal to each other. Okay, the reason I can have this because let me erase this. Okay, due to A is different from B, it's not equal to B. Okay, with this definition, then I can write set A. Okay, set A given like this, 2468. I can write that set A is a proper subset of set A. Okay, set A is a proper subset of set A. Okay, but I cannot write that. Oh, I'm sorry. I think I have a mistake over here. Okay. Let me think a little bit over here. So I can write this A is a subset. Okay. A is a subset of set A because according to the definition, we already know the remark over here. So because element of A is also in there, right? So A is a subset of itself. Okay. However, if we write A is a proper subset of A, if we write like this is wrong. This is wrong. Okay, because according to the definition of proper subset, the A cannot be equal cannot be equal to B. So over here, okay, let me use the different set. I mean, it's easier for you to see. What if I have two sets, a set B over here? It's kind of the same element, but I just change a little bit. What if I have 4, 8, 6, 2? Okay. Okay. So I can write. Okay, I can write that. Okay, I can write that. Okay, I can write that A is subset of B. Okay, because element of A is inside B. Okay, but if I go ahead and write, A is a proper subset of B, okay, that would be wrong. That would be wrong because according to the definition, is a proper subset. It cannot be equal. Okay, but over here A and B are equal to each other. So if we write like this, it would be wrong. Okay, so that is the only case. That's the only case when we write. This is wrong when we write like this. Okay, that's the only case. Okay, we have to write with the subset symbol instead of the proper subset symbol for this case. Okay. However, if you look at this example, we can either write A is a proper subset of B or A is a subset of B. In this case, that'll be okay. Okay. All right. Another example I want to add over here is that because we know in the remarks, we know that every empty set is also the subset of every set. So we can also say that empty set, null set, is the proper subset, okay, of any set. Okay, we can also write like this. So either we use the proper subset symbol or subset symbol. Both cases will be allowed. Okay, so I'm gonna put a remark over here. So this is the first remark number 1, and this is remark number 2. So in the remark number 2, I can say that empty set is proper subset of any set. Okay. So given any set, we can write that, and we can write empty set is the proper subset of that set. Okay. Good. All right. Now, let me let me have another example, and example number 4 over here. I don't know, I cannot erase this. I don't know why. Okay. Alright. Example number 4. I have two set letters. I have set A, and I can write it in set builder notation. X with X is person living in Atlanta. Okay, person living in Orlando. Let's say Orlando. Okay, and set B, okay, is also a person, a collection of person living in Florida. Okay, now let's go ahead and use on set symbol. set notation and see how's the relation between set A and set B over here. So Orlando is a city in Florida, so I can say that people living in Orlando is also living in Florida. So I can say that set A over here, right, is the subset of set B. Okay, but because the people living in Orlando is not it's not the same as the number of people living in Florida, because the number of people living in Florida will be bigger, will be larger, many more. There's only I believe there's only few million people living in Orlando, but there are about like 20 million people living in Florida. So if you compare the number of people living in Orlando, Florida will be different. So the collection, the set over here is not equal. And if it is not equal, then I can write set A is the proper subset of set B. So there are two ways to represent subset and proper subset in this case. Okay, we can write with the proper subset symbol, or we can write with the subset symbol. In both of the cases will be the same. Okay, that's why I say the only case when you cannot write A is a proper subset of B is that when we have set A and set B equal. Okay, if set A and set B equal, then we cannot write it. So I'm going to add over here is due to set A equal to B. So if it's set A equal to B, then we have to write like this. Okay, we cannot use the proper subset symbol to express the relation between two equal sets. Okay, remember that. That's the only case. Okay, between the only difference between and the only case that's different between proper subset and the subset. Okay, good. All right. Now, so you see that in this example, in the remark over here, I say that every set is a subset of itself, and empty set is also the subset of every set, of any set. Okay, empty set is a subset of any set given. Then the question is, how many subsets can we have out of a set? Given a certain certain set, right? How many subset can we create out of that set? Okay, so the answer for that question will be on the third part of our lecture today. Okay, so on the third part of our lecture today, I would like to discuss the number of subset of a given set. The number of subset of a given set. Okay, now let's see how many subset can we create out of certain set. Okay, let's see. Now before I jump to the formula, it helps you to calculate the number of subset out of a certain set. Let me give you the example. What if I have given? Okay, what if I given and in the first case over here, I have an empty set. Okay, an empty set. This is an empty set. Now I try to create a subset of an empty set. So we know in the remark that every empty set is a subset of any set. That's what we know. The empty set is a subset of any set. So from here, given this subset, given this set over here, so I can write. I can get the subset out of this. Okay, so I can get the subset given this set. So the subset I can get, okay, is also an empty set. Okay, and the subset over here is also an empty set, because empty set is subset of any set. So empty set will be subset of the empty set. Okay. Now what if I have set A? Okay, and set A over here has only one element. Let's say that I have this element. Okay, then I can find a subset. Okay, and a subset. Okay, subset will be what? Will be the empty set, right? Because empty set is subset of any set, so this is this set over here, and we also have another set is the set of itself, because all the set has itself as a subset. We already know that. We already know it here. Okay, every set is a subset of itself. So we can have we can create another set which is itself. Okay, so you see that if you have empty set, then we have one subset. If we have a set which contain one element, then we have two subsets. What if we have a set that contain two elements? Okay, two elements. Then how many subsets can we create? Let's see. So the only subset we can have is the empty set. Okay, we have a set we have a subset of itself. Okay, besides we also have a subset that contain only element A, or we have a subset that contain element B. So totally we have four subset over here. So now what if I have another set, but instead of contain two elements, they have three elements. So let's see how many subsets we get. So over here we have four subsets. I have four subsets. Well, I cannot erase this. Okay, so over here we have four subsets. So this is only one subset. So over here, this one we have two subsets. Okay, and over here we have four subsets. Okay, now what if we have a set with three elements? Let's see how many subsets we can get. Subset. Okay, so we have empty set. We have the set of itself. So we have A, B, C. Okay. Then we have A. We have B. We have another. Yeah, we have C. Okay, they all subset. Then we have AB. And then we have AC. And then we have what else? BC. All right, what else? That's it, right? So totally we have 1, 2, 3, 4, 5, 6, 7, 8. So we have a subset. Okay, we have a subset. So we have one subset, we have two subset, we have four subset. This is 8 subset. So look like that given a set, given the set, we can find the number of subset by raise base 2 with n power. Okay, so the number, so the number of subset we can create will be 2 raised to the n power, and n in this case represent n is the number of element. Okay, so it's the number of element. Okay, so with this formula over here, we can find the number of subset. Now, what if I given a set and instead of finding the number of subset, they want you to find the number of proper subset. Okay, so from here, okay, so from here we can also find the number. Okay, the number of proper subset. So proper subset. Okay, and proper subset is a subset that does not have the same element, right? So it means that, for example, in this case, we're not gonna have set C. In this case, we're not gonna have set C here, and we're gonna have set C over here. So it means what? It means that the formula is kind of the same, but we have to subtract by 1. So instead of having 8 subset over here, we're gonna have only 7 proper subset. We have only 3 proper subset, and we have only 1 proper subset. Okay, and we have one proper subset over here. Okay, so there's only, so n is okay could be 1. Okay, we don't have n equals 0. N equals 0 mean so we have 2 to the 0 is 1 is 1, so we don't have any subset. That could be, it's not the case. Okay, so and in this case, okay, and it's also the element of the set. Okay, it's kind of same thing. And is the element, the number of element. Okay, so whatever n equal 1, then 2 will be only one subset instead of 2. Okay, now let's jump to the example. What if I have something like this? Okay. Example 1. Given the set over here, given the set A, and fill element over here. So let's say they'll have I have Dell. Okay, HP. I have MSI. So different branch of laptop. Then I have Alienware. Okay. Okay. So this set over here is include 4 elements, and they are all laptop brand name over here. Okay. And the question is how many subset we can create. So from here we can say that because this is a 4 element, the cardinality is 4. Okay, so we have 4 elements. So totally we have 2 to the 4, which is 16 subset. Okay, 16 subset. However, we have only 2 to the 4 minus 1, only 15 proper subset. Okay, proper subset. Alright, so that is how you find the total number of subset or proper subset you can create out of a given set. Okay. All right. We can do another example. What if I have a set A over here and write it in set builder notation? X and X is belong to natural number set, and X is between 3 and 8. So between 3 and 8 will be equal sign. So over here we can get the cardinality of set A will be This is we have an equal, so we have 3, 4, 5, 6, 7, 8. So they have 6. So from here I can find the number of subset we can create of set A will be 2 to the 6, and the number of proper subset will be 2 to the 6 minus 1. Okay, so 2 to the 6, you know that this is be 64, and will be over here it will be equal 63. So we have 64 subset, and we have 63 proper subset. Okay. All right. So you already know what subset is and what proper subset is. So in the next video, I will show you how to express, how to display the set by using a very special diagram we call Venn diagram. Okay, and we will be learning in the next video. We'll be learning when we have two sets intersecting each other, and we will be talking about intersection concept and union concept. Okay, but for the section 2.2, I'm gonna stop over here. If you have any question, please let me know. Okay. I try to train with my handwriting a little bit, but if you cannot recognize my handwriting, or if you spot any error over here, could be any typo, please let me know. Okay, but I'll try to fix my handwriting better so that you guys can recognize easily. Okay, I'll be seeing you next time. All right, bye bye.